Well, good day to you each, and it's Super Bowl Sunday. Time to have a review for quiz number 3. For those of you that are keeping up, you know you have 3 sections of work due on Monday, 3-2, 3-3, and 3-4, and you have a quiz due on Tuesday at the end of the day. So make sure you go to your Hawk site, hit View Course, and see what is due when, and be sure and take care of those assignments. Remember, while you can turn in an assignment late, you may not do a late quiz. So once the Tuesday midnight deadline has passed for a quiz, that's it. All right, so let's review for quiz 3. Remember that the YouTube channel with my name, just go to YouTube and put in my name, and you will find all of my videos, among which are the notes on 3-2, 3-3, and 3-4, and the problem sets on 3-2, 3-3, and 3-4. If you haven't looked at that before you look at this, some of this is going to look unfamiliar. So there's an order of things to do. Look at your YouTube videos, download your notes under Blackboard Content, and then check out the review for quiz number 3. All right, here we go. And as we go, I've got my handy-dandy calculator close. Always keep that close for when you're doing your work. All right, consider the following equation. Considered. First of all, find the X and Y intercepts if possible. Now, if you will look at your YouTube video on this section 3-2, you will know that if you have a linear equation that has x's and y's in it, as this one does, x, y, it is a slanted line, i.e. it is not a horizontal nor a vertical line, it is a slanted line. And as such, every slanted line will have both an X and Y intercept. So with this guy having both X's and Y's in it, it's going to have both an X and a Y intercept. I know that just by looking at the equation. If you have an equation that has only X's, you have yourself a vertical line. Example of that would be 3x equals 17. Hey, look at that equation. It only has x's in it. X's only. This describes a vertical line, and a vertical line, of course, will only cut the x-axis. Any vertical line will only cut the x-axis, so this has x-intercepts only. Equation with only y's, yeah, you can probably guess, is a horizontal line. And any horizontal line, like 7y equals negative 19, hey, that equation only has y's in it, so it must be a horizontal line. Any horizontal line will only cut the y-axis, so it has a y-intercept only. Now, you can come to this conclusion just by looking at the equation. Does it have x's and y's? X and y-intercept. Just x's? X-intercept only. Just y's? Y-intercept only. All right? This guy has both x's and y's, so I should be expecting to find both the x and the y-intercept. Now, here's the question. How do you find an x-intercept? If you'd looked at your notes, you would know that there is a strategy. To find an x-intercept, you let y equal to 0 in your equation, and you solve for x. So I'm going to, in this equation, substitute 0 for y. That was easy. Hey, 0 minus x is just negative x. I'm not finished because I'm not solving for negative x, I'm solving for x. So I can multiply or divide both sides by -1. Or you could say, hey, change the sign of everything on both sides of the equation. Same result. X is -1/2. So my x-intercept is going to be the point -1/2, 0. X-intercept always has a y value of 0. Let y be 0. How about finding a y-intercept? A very similar strategy. I let x equal to 0 and solve for y. So in my equation, I'm going to let x equal 0. In the place of x, I put 0. It's going to be easy. Y minus 0, that's just y. Y is 1/2. So this tells me that my y-intercept, which has an x of 0, is going to be 0, 1/2. So there's your strategy. To find the x-intercept, you let y equal 0 and solve. To find the y-intercept, you let x equal 0 and solve. Second part says graph the equation of this guy by plotting the x and the y-intercepts. If an x-intercept does not exist, where you would have a horizontal line, then you're going to have to pick another point. If the y-intercept does not exist, like a vertical line, you're going to have to pick another point. But right now I have both x and y-intercepts. So here we go, 0, 1/2, and notice this is 5 right here. So 0, 1/2 is like right there. And -1/2, 0, -1/2, 0 is like right there. So I always keep my straight edge handy with these 2 points. I can find the graph of my particular line. And there it is. Now on your hawks, you're going to pick the point and click on it and it'll solidify. And then you're going to pick the second point, click on it, and when that solidifies, the line will be defined. So you pick your 2 points, that will define your line. All right, not too bad. X and Y intercepts. All right, problem number 2. It says consider the following equation. There it is. Hey, notice x's and y's. We know this guy is a slanted line. It has both an x and a y-intercept. But that's not what they asked me here. They say express the given equation in the slope-intercept form. Now you guys know that the slope-intercept form is y equals mx plus b, where m, the number in front of the coefficient of x, is your slope. And b, the constant number at the end, is your y-intercept. So what this tells me, basically, if I want to find the slope-intercept form of any line, is I need to solve for y. Another way of saying what to do here is solve for y. Get y all by itself. There's y. It's hanging around with a 1. It's hanging around with a 4x. So I'm going to take my steps to get y by itself. I'm going to subtract 1 to start with. And I'm going to get 4x plus y equals -1. Y is not quite by itself yet. I'm going to subtract 4x. And some of you guys would do both these steps in one. The more sophisticated of you, the more comfortable in this process. And I get y is, I'm going to put my x's first, then my constant number at the end. So my x is first. And there is slope-intercept form. Express the given equation in slope-intercept form. Done. And nothing to simplify. We're good to go. So that's it. So again, slope-intercept form, solve for y. All right, step 2. Given that x is 1, find the value of y. So in my new equation, and you could use the old one if you wanted to, but this one is all nice and handy, solved for y. I'm going to let x equal 1. So in the place of x, I'm going to put 1. Hey, that's easy enough. Now let's evaluate. -4 minus 1. Y is -5. Well, that's easy enough. So basically all we're doing is substituting and solving. Same thing here. Given x is 2, find y. All right. My equation. Oops, yeah. X is 2. So in the place of x, I put a 2. So I get y is -9. Not bad at all, huh? So once again, slope-intercept form, solve the thing for y. Given a value of x, find y. Substitute and solve. All right. Problem number 2 is history. Actually, it's math. Let's find problem number 3. Find the equation of the line in slope-intercept form again. That's y equals, right? Let's remind ourselves that passes through the following point with the given slope. Simplify your answer. Okay, this is from this section in which they're asking for the equation of a line when given certain bits of elementary information. For instance, they'll give you the slope and a point. They'll give you 2 points. They'll give you a point and a line that's parallel to your line, or they'll give you a point and a line that's perpendicular to your line. So they can give you a variety of bits of information and ask for the equation of the line. But my important foundational principle to remember is slope-intercept form. Notice the slope-intercept form of the line. It has 1, 2, 3, 4 variables. An x and a y, an m for slope, and a b for y-intercept. Now please notice, when you are given a point and the slope, you are in fact given 3 of the 4 variables. Really? How's that? Well, every point, seems like an elementary concept, but it's very important. Every point is in fact an x and a y. So that when I have the slope-intercept form of the line, I have x, I have y, I have m, I have everything but b, which reminds me that all I have to do is substitute my 3 variables in order to find my 4th missing variable. So here we go. Y is 3. I'm just substituting. M is -1. X is -8. Don't forget the negative. Plus, that's the one thing I don't know, b. Negative times a negative, positive. Just about got b by itself. Subtract 8 from both sides, and I've got b. Use your calculator if you need to manipulate positive and negative numbers. -5, b is -5. Now, once I have the slope, there it is, and the y-intercept, there it is, I can come up with the general equation of the line in slope-intercept form. And it's simply going to be this. Y equals m, got it, times x plus b, got it. Now that's kind of a clumsy way to write this equation, so I'm going to smooth it out a little bit. We typically don't say -1 times x, we say negative x. We typically don't say plus a -5, we say -5. And there it is. Again, notice the general equation of the line in slope-intercept form does have x and y in it. So I'm not going to substitute this guy back in there. That's just going to give me a tautological statement, which is something like 10 equals 10 or something. It's not helpful. So my slope-intercept form is y equals mx plus b. I substitute for m. I substitute for b. Hey, that wasn't too bad. We used our 3 variables to find the missing 4th variable. Then we substituted m and b in the equation for our line and slope-intercept form. Hey, 3 out of 4. One more to go. Again, it says, consider the following equation. Notice something about it, x's and y's. We know this is a slanted line. We know at least that much. Let's see what we're asked to find. Express, and there it is again, slope-intercept form. Remember, that's y equals mx plus b. Don't forget what that means. That means solve for y. That's how you put an equation in slope-intercept form. You solve for y. So let's solve this guy for y. Now notice slope-intercept form, the y is on the left. That's the traditional way of writing it. So we're going to get our y's on the left. This is going to be my y side. So I'm going to subtract 4y from both sides to eliminate the y's on this side. Adios. I want y only on this side, so I don't want this x, so let's get rid of x's. Remember the slope-intercept form, the x's come before your constant number. So let's write it that way. The x's first, x's, then the constant number. Hey, it looks pretty good. Oh, I got to solve it for y, not 3y. So I'm going to have to divide this guy by 3. Every term by 3. So that tells me that y is negative x over 3 minus 7/3. Express the given equation in slope-intercept form. Looks good to me. Now, one thing I'm going to be asked to do down here is to identify the slope of this line. Can you look at this term right here and figure out what m is? Can you look at this and express this, at least in your mind, as something times x? It's not real obvious. It's kind of subtle. So let me readjust this guy until it's very much so literally in this form, a number times x. Because right now it's negative x over 3, right? Kind of confusing. So let's rethink this. Another way to think of x is 1x, right? And as soon as I do that, I can see what the coefficient of my x is. It's negative 1/3. So that's the same as y is negative 1/3 x minus 7/3. Now, Hawk should be very happy with either one of these expressions for this, but I have to have this concept at least in my mind if I'm going to find the slope of this line. So this slope is negative 1/3. Why is that important? Yeah, let's find out. Step 2, find the equation of the line which passes through the point 5, 3, here's my point, and is perpendicular to this line right here, this guy right here. Now, one thing you should know is that slopes slopes, one of those guys, slopes of perpendicular lines are, are you ready? Negative reciprocals of each other. So if you have the slope of one line, if you want to find the slope of the line that's perpendicular to this guy, you got to do two things. Negate it, change the sign, take the reciprocal, flip it. So you got to do two things. Change the sign, reciprocate. So as I look at this line, its slope is negative 1/3. My line is perpendicular to this guy, so my line is going to negate this guy and flip it. So it's going to be positive 3/1, or just 3. So again, if you have two lines, L1 and L2, that are perpendicular, then L1, let's say, has a slope of -2. Then the slope of the line that's perpendicular to it, I got to change the sign. It's going to be positive. And I got to think of this as a fraction and flip it. So it's going to be positive 1/2. If this guy is positive 5/3, then the slope of the line perpendicular to it is flip it and change its sign, -3/5. Gets a little bit funny when you have something like how about this one, 0.7. Can you come up with the slope of the line perpendicular to that? Well, only if you think of this guy in other terms other than a point. 0.7, another way of saying 0.7 is, anyone? That's right, 7/10. So if I can think of 0.7 as 7/10, it's easy to reciprocate it, flip it, and change its sign. Not bad at all, huh? All right, so my line goes through the point 5,3 and has a slope of 3. And as I remind myself, that is exactly like problem number 3. I got a point, I got a slope. Let's fill in what we know. Y equals mx plus b. I'm going to fill in what I know. This is my x. This is my y. 3 is slope, which is 3, times x, which is 5, plus b. Let's see. 3 equals 15 plus b. I'm going to subtract 15 from both sides. That gives me b is -12. And once I have both the slope and the y-intercept, I can easily write the equation of my line. Y equals the slope times x plus my y-intercept minus 12. And there you have it. So good luck to you on quiz number 3. If you went to the volleyball game on Friday, that's impossible because it got canceled. If you went to the basketball games on Saturday, either one of them, let me know and I'll give you some extra credit for that. All right, good luck to you, and I'll see you on the other side.